Hi everyone, today we'll discuss Laplace transformation multiplication by t. The statement of the theorem is first we'll prove this theorem, then we'll do the problem based on this. I'll make one video on this, then another video on the problem. Okay. If f of t is succe- uh, if f of t is successionally continuous and exponential order, and if a Laplace transformation of f of t equal to f of x, then Laplace transformation of t f of t equal to minus f derivative of the function. Okay, let's go with this. So proof, let's prove it. We have what we have 0 to infinity e to the power of minus st f of t dt is f of s. So this we have. We know from the definition of Laplace transformation. It is Laplace transformation of f of t. We know this. We have or we know. Now, one property we are using by Leibniz rule for differentiation under integral sign, under the integral sign. What we have, f of s equal to 0 to infinity e to the power of minus st e to the power of minus st f of t dt. By the Leibniz theorem, what we have, the Leibniz rule says for the differentiation under the we are differentiating both the side by d by ds. D by ds. Here also d by ds. If you take this d by dx inside, it will become partial dou s by dou s. So, okay, dou by dou s. Okay, next. So this I am writing. This I am writing. Where is my pen? We are writing f dash x equal to 0 to infinity. If you differentiate it, differentiating partially with respect to yes, it will be minus t e to the power of minus st f of t dt. What we are doing is here multiplying by minus. So I am taking minus outside, minus f dash x equal to 0 to infinity e to the power of minus st. This t I am taking here t f of t dt. This is by the definition what we have, Laplace transformation of t f of t is same as minus f dash x. So this is the proof we have done. Now the same thing, the extension for this, what is this, Laplace transformation of t to the power of n f of t equal to minus 1 to the power of n d2 dn by ds of f of s. This is the extension. We will prove by mathematical induction. What is mathematical induction? If it's true for n equal to 1, we will assume that it is true for n equal to m. If it is true for n equal to m plus 1, hence by induction, it is true for all values of n. So we will go by mathematical induction, the extension of the theorem. So extension of the theorem, we have t Laplace transformation of f of t is minus f dash of s, f dash of x. This is from the above proof. So therefore, it is true for n equal to 1. One part. This part we have. Let us assume that let us assume that let us assume that the given statement is true for n equal to m. Let us assume that the given statement is true for n equal to m. So that means Laplace transformation of t to the power of n f of n equal to minus 1 to the power of n minus 1 to the power of n minus m to the power of n, or we can write like this now, d by ds. Why we are writing this? N to the power of n, d to the power of n by ds to the power of n f of s. F of s. This is, we are assuming that it is true for n equal to m. Now we will go, we will prove that it is true for n equal to m plus 1. Again differentiating with respect to x, applying Leibniz rule. So this will be this will be this will be 0 to infinity e to the power of minus st t to the power of f of t dt equal to minus 1 to the power of n dn by ds to the power of n f of n. So what we are doing, differentiating with respect to x both the side. So d by dx ds, here also d by ds. If you take to this side, this will be if you take inside, if you are differentiating partially with respect to s, so e to the power of a minus t e to the power of minus st minus t, this is not minus 1, minus t t to the power of n f of t dt. This will be minus 1 to the power of n. One more is there, so n plus 1 by ds of n plus 1 fn of s. Now a small adjustment here. This minus, if I take over here, 0 to infinity e to the power of minus st. T is there, t to the power of n. So t to the power of n plus 1 f of t dt. This minus, if I take to here, minus 1 to the power of n plus 1 d to the power of n plus 1 by ds to the power of n plus 1 f of s. Hence, it is true. Hence, the given statement is true for n equal to m equal to n plus. Hence, by mathematical induction, it is true for all n. That means Laplace transformation of t to the power of n f of t equal to minus 1 to the power of n 1 to the power of n d to the power of n ds to the power of n f of s. This is our proof. Very easy proof. It required some patience from your side. See here one more time. First, what is that? Multiplication by t. We are doing multiplication by t. So Laplace transformation f of t equal to f of s. Then Laplace transformation of t f of t equal to minus f dash a. The function is sectionally continuous. We have 0 to infinity e to the power of minus st f of t is f of s, a Laplace. By applying the Leibniz rule, if you differentiate outside, it will be dsy total derivative. If you take the integral size, it becomes partial derivative. Please remember, it is Leibniz rule for differentiation. So with that, e to the power of minus st is minus t. Then you see, this is the same thing. Don't get confused. differentiate d by dx of e to the power of ax is a into e to the power of ax. This will come here. So here t is the t will come here because we are differentiating partially with respect to s. Tf of t. What is Tf of t? The same function is 0 to infinity e to the power of minus st. This is the whatever is there. This is Tf of t minus f dash. That's it. Now this extension we are doing, we are proving by mathematical induction. The given statement is true for n equal to 1. Then we will assume that the given equation is true for n equal to m. Then if we are able to prove the given equation is equal to n plus 1, then for all values of n it is true by mathematical induction. We prove by mathematical induction. This one, now we will go for the problem. Okay, please subscribe my channel and share with your friends. I am making all M1 I have completed. I have uploaded all the important problems from M1 engineering math. Now M2 I am working on M2. Please do subscribe and share my channel with your friends.